when we talk about polynomial long division, what I want to start with is just an example of regular long division from way back in the day. You probably would learn this in 2nd or 3rd grade. But I think if you can do this with regular long division, you'll see that polynomial long division follows the same similar method, I should say. All right. So what we're going to do first is we have to find out, like with this 5 here, we're going to ask ourselves, what 5 goes into 6 how many times? You got to start with that. And we'll say 5 goes into 6 one time. And then we can put a 5 below the 6. We'll zoom in here. And what happens is we say 6 minus 5 is 1. And then we're going to drop the next number down, which is a 7. And we have to ask ourselves, 5 goes into 17 how many times? And you might remember when you did this as a kid, you would say, okay, well, like 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 20 is too high, so it's got to be 3. So 5 goes into 17 3 times, and 5 times 3 is 15. So that's the number we put below the 17. And then we do subtraction again, and we get 2. And then we drop the 9. So then we have 5 goes into 29. Turns out it goes into 29 5 times. And 5 times 5 is 25. So we end up with our remainder of 4 here. That's how long division works. And we want to try and keep things pretty well organized, where we keep things lined up above each other. All right. And we're going to see the same thing when we do polynomial long division today. We're going to do this very similar method. But before we start getting into polynomial long division, let's just review some vocabulary, some division vocabulary. So we're going to talk about 4 things here. We're going to talk about the dividend, the divisor, the quotient, and the remainder. So start with the divisor here. The divisor in this example is the number 5. All right? And that is the number we are dividing by. Okay. Next is the dividend. That is 679. That is the number being divided. We have the quotient, which I'll highlight in red here. That is 135. That happens to be the solution on top of the division bar. And finally, we have the remainder, which in this case was the number 4. And the remainder is the part left over. That cannot be divided evenly. All right. And typically the way we'll write a remainder is like this. We'll say 4. You might remember that you would have done like R4 back in elementary school, but we're not going to do that today. We're going to write it as like a fraction. We're going to say 4/5. So what I want you to do is write your remainder as a fraction. And you're always going to write the remainder over the divisor. As a fraction over the divisor. That's really important there. We're not going to worry about decimals right now, so nothing with decimals. We're just going to leave our answers with a fraction at the end. And the reason is because when we do polynomial long division, we're not going to be worried about decimals. So you're absolutely right. We could do this with decimals answers and get like 135.8, but we're not going to do that. We're not going to do that today. All right, just because of the polynomial problems. All right. So in general, what polynomial long division is going to look like when you divide a dividend, I'm going to try and keep the colors the same, f of x, by a divisor, we'll call the divisor d of x. You're going to get a resulting quotient polynomial, which will be q of x, and a remainder r of x. And what this is going to look like when we have this f of x, d of x, q of x, r of x, it's going to be f of x divided by d of x. That's your dividend divided by your divisor. Your result should be a quotient plus, like I said, whatever your remainder is divided by that divisor. And this looks really intimidating, but I'll show you what it looks like after we do a physical problem. One quick note I want to mention here is that you have this plus sign here, and that could sometimes be a minus, and we'll see an example of this, but the sign is going to be determined, if I can spell determined, there we go, by the sign of the remainder. Sometimes you can have a negative remainder in polynomial long division. Okay. So the sign is determined by the sign of the remainder. Now, any questions so far on just regular old long division before we move into polynomial long division here and take a look at this first example? No? Okay, great. So when we do polynomial long division, keep in mind that we have our dividend. It's going to be this x cubed plus 5x squared minus 7x plus 2, and then our divisor is x minus 2. So we'll start by putting x minus 2 outside of the division bar. Inside the division bar, we're going to do x cubed plus 5x squared minus 7x plus 2. And whenever we want to do polynomial long division, what we want to do first is we kind of want to ignore this minus 2. So I'm going to kind of cross it out right now for just my own self. You don't need to cross it out on your paper. But I'm just showing you that we want to focus on the x first. And we have to say x times something equals x cubed. We want to get an x cubed down here. So x times what equals x cubed? That's what we want to start with, that question. X times what equals x cubed?
X squared?
Yes, exactly, x squared. So what we would do is we would put an x squared up here and say that's going to be the first part of our quotient. And notice where I put the x squared. I want to put the x squared directly above the other x squared. When I'm done, I'm going to have all the x squareds lined up. I'm going to have all the x's lined up in a column. I'm going to try and keep my work nicely organized. That's what's going to make me very successful at polynomial long division. Anyway, so I got rid of the, I just covered the -2 temporarily, and I said I'm going to multiply x squared. So what happens is I go x squared times x, and that gives me my x cubed. Well, I'm also going to have to do x squared times this -2, and that's going to give me the second part of the term, which is -2x squared. So I'm going to erase all these arrows. But I'm going to get a -2x squared here as well, because now I'm multiplying by that -2. So I ignored it at the very beginning to figure out what number needs to go on top, but then I got the -2 there. And just like before in the long division up above, I need to subtract this term from the one above it, polynomial subtraction. But what we learned about polynomial subtraction yesterday is we technically need to distribute this to all of these, and we're going to change the signs. So this should become a, this should become a -x cubed and a plus 2x squared. All right, so just remember the polynomial subtraction means you need to change all of the signs. Okay, and what should happen is in this first column we get x cubed minus x cubed. That should be a 0. And that should happen every single time if we're doing polynomial subtraction correctly. And then the second term, we're going to get 5x squared plus 2x squared. 5 plus 2 is 7, so we get 7x squared. And then we're going to drop the next term, minus 7x. And then we go back to our divisor, the x minus 2. I'm going to cover up the 2 again temporarily. And I'm going to ask myself, x times what equals this 7x squared down here? X times what equals 7x squared? And it turns out it's going to be a positive 7x. That's where I get that number from. So I just cover up the 2, and I look at myself and say, x times what equals 7x squared? It turns out it's going to be a 7x. So that's how I would get the 7x squared. And then I also have to multiply that 7x times -2. And that gets me negative 14x here. And then I'm going to once again distribute the negative through, and I'm going to get a minus 7x squared. And it becomes a plus 14x. And I get 7x squared minus 7x squared is 0. Perfect. Negative 7x plus 14x is positive 7x. And then drop a 2. And then for the last time, once I have this new line, I'm going to cover up the 2 one more time and ask myself, x times what equals 7x? Turns out it's going to be x times 7 equals 7x. And then 7 times -2 is negative 14. And for the final time, I'm going to have to distribute this negative through for my polynomial subtraction. And I get a negative 7x plus 14. And I get 2 plus 14. I get 16. It's a positive 16, so I'm going to say plus, and I'll write it in blue because that's my remainder, 16 over my divisor, x minus 2. And then this line here, I'm just going to replace it with red, just because that was the color for our quotient. So I'm just going to try and stay consistent with my colors here. So again, our answer was x squared plus 7x plus 7, and then plus 16 over x minus 2. Okay. So it always comes out to remember when we take this top number here, like this x squared, I'm going to, let's do it in a different color here. We'll do it in purple right now. I'm going to take this number, I'm going to multiply it by x, and that's where the x cubed comes from. Then I'm going to multiply it by -2, and that's where the -2x comes from. And then I move to the next term, and I'm going to take this 7x, multiply it by x, and that's where I got 7x squared. And then I'm going to take 7x and multiply it by -2, and that's where I got -14x. All right, that's what's happening every single time. Okay, so it's just about finding that term on the top line and then using that. Okay, so one of the goals of polynomial long division is I should have all the x squareds lined up at the end. I should have all of the x's lined up at the end, and I should have all the constants lined up at the end. So just something to keep in mind to show that you're doing it the correct way. We're going to do another example so I can show you again what's going on. All right, so we'll do another example in a minute. First, what I want to do is I want to take our answer and I want to double check it. So what really happened here, just we have the f of x over d of x up above. So I'm going to write that notation up here. X cubed plus 5x squared minus 7x plus 2. That was divided by our divisor, x minus 2. And as a result of our division, we ended up with our quotient, x squared plus 7x plus 7, and then plus our remainder, 16 over x minus 2. That's what our final values looked like. Now there is a way to double check this, and the way we can double check it is by actually doing the opposite of division. The opposite of division is multiplication. So I should be able to take my answer, x squared plus 7x plus 7, and multiply it by the divisor, which is exactly what we're doing anyway. And hopefully you'll see these numbers again. And now I can say x times x squared is x cubed, x times 7x is 7x squared, x times 7 is 7x, -2 times x squared is -2x squared, -2 times positive 7 is -14x, -2 times positive 7 is -14. And I'll have my like terms, so I have a positive 7x and a -2x. So I'm going to get an x cubed plus 7x squared minus 2x squared is positive 5x squared. And then plus 7x minus 14x is -7x minus 14. One thing is I want to point out to you is in this entire box is, for example, like I have x cubed, 7x squared, and 7x. Those should be the first numbers from the division in each column. X cubed, 7x squared, 7x. They line up. When you're undoing it, you should see those numbers again. The next row, -2x squared, -14x, -14. -2x squared, -14x, -14. Those numbers are obviously before we distribute that negative, but we should get the same numbers. Now, when I got my... What's up? Question?
So the number at the end doesn't matter?
What do you mean?
The +2, which became a -14.
Well, yeah, actually, that's what I was going to bring up. So what happens is we have x cubed plus 5x squared minus 7x. But yes, now there's a weird thing. I have a +2 instead of a -4. I have a -14 instead of a +2. But what's one number I haven't taken into account yet? When I did the multiplication, I just kind of ignored one number here that was still part of our answer, which was the remainder, right? Our remainder was +16. So if I can take my answer here, and I can say, let's add 16 to it, just polynomial addition style, -14 plus 16 is +2. So you take your quotient and you multiply by the divisor, and then you add your remainder, and you're going to get back to where you started. So that's how you can double check your answer that you did your division correctly. So you can always double check your division on any one of these problems. Okay, that's what these. That's one of the tricks with these polynomial long division problems. Now I know that's a really long explanation, but that's what polynomial long division's going to look like. All right, just like our regular long division by hand, except now we're going to have variables in there, x's and stuff to keep track of, and we want to try and keep it nicely organized with nice, neat columns. Keep the x squareds in one column, keep the x's in one column, keep the constants in one column. That's always going to be the goal. Okay, any questions on this first example, which I've talked about for a while now, but any questions at all on this before we move on to one more example? Okay, so last example here today that I'm going to work on, and then I'm going to have you guys do a couple practice problems. Problem number 2 here. It says divide f of x equals 4x cubed minus 6x squared plus 7 by 2x plus 6. So we'll set this up, and we'll say here's our 2x plus 6 right here. And something I want to point out here is the 4x cubed minus 6x squared plus 7 is missing a term in the middle here. It's missing the x term. So what we're going to want to do when we create our division, we're going to want to put a placeholder in there. It's like if I were doing 209 divided by 15, I'm going to have a 0 in there as a placeholder. So I'm doing the same exact thing here with polynomial long division. I got to put a 0x placeholder in there. One thing you can always do to identify a placeholder is start with identifying the degree of the polynomial. This is a 3rd degree polynomial, and it should have 4 terms in it. Always one more term than whatever the degree of the polynomial is, because you're going to have the x to the 3rd term, the x to the 2nd term, the x to the 1st term, and the x to the 0 term. That's why it should always have one more term than the degree of the polynomial. Okay, so if you see a 4x cubed, you should count how many terms are there. There's 1, 2, 3 terms. I need one more term, so there's got to be a 0 placeholder somewhere. Okay, that's something you'll want to get used to and hopefully recognize. Anyway, so in this example, I'm going to add that 0x placeholder. And again, the placeholder is so that way I can keep all of my x's in one line, in one column together. It's going to help me stay organized. Now, I start with ignoring this plus 6. I'm just looking at 2x. Something times 2x equals 4x cubed. And it's going to have to be a 2x squared. And I'm going to line that 2x squared right up over the negative 6x squared. And then I can say 2x squared times 2x is 4x cubed. Perfect. 2x squared times positive 6 is going to be positive 12x squared. Then I'm going to distribute the negative through here, change the signs, and I'm going to have a 4x cubed minus 4x cubed is 0, that's perfect. Negative 6x squared minus 12 more x squared, negative 18x squared. And then I'm going to drop my 0x placeholder down. And I have to say 2x times something equals negative 18x squared. And 2 times negative 9 is going to get me negative 18. X times x is going to get me negative 18x squared. So it's going to be negative 9x times 2x. And then I can say negative 9 times positive 6 is negative 54x. Then I'm going to distribute the negative again. It's going to change both of these to positive numbers, actually. And then I can go ahead and go down the rows. Negative 18x squared plus 18x squared is 0. 0x plus 54x is 54x. Drop the plus 7. And then ignore the plus 6 right now. I'm going to say 2x times what equals 54x? Turns out it's going to be 27. 27 times 2 is 54. 27 times 6 is 162. And then I need to change the signs. Negative 54x, negative 162. And 54x minus 54x is 0. 7 minus 162 is negative 155. So this one should be minus 155 over 2x plus 6. This is where I was talking about the sign of the remainder is what the sign is going to be at the end here. It's going to be a minus instead of a plus this time because I have a negative remainder. 2x squared minus 9x plus 27. All right. The key for this problem to be successful is that 0 placeholder. It helps me keep everything organized, and now all of my x's were able to stay in the same column. All right. Otherwise, you'll get to this type of problem without the placeholder, and you're gonna get stuck, and you're gonna say, "What did I do wrong? I can't figure this out." So pay attention and make sure you always identify those placeholders when you need to. All right, on any of these types of problems. All right, so that's example number 2 there with the 0 placeholder. All right, I got the 162 here. Let me do that in a different color. I got this 162 because I did 27 times 2x, and that gave me a 54x down here. And then I did 27 times positive 6, and that gave me 162. Okay, that's where those 162 came from there. All right, so today's lesson, I think that's pretty short, but I think it's tricky because this polynomial long division, it's just, you got to be organized, you got to be careful with it. All right. Okay, I've got these 2 answers up here so you guys can double check your answers. Just hopefully you're feeling okay with this stuff. If you have any more questions on this stuff today, please let me know. If you want to stay on the Zoom call and work on assignment 24, please do. If you want to work on assignment 23, 22, 21 and get it ready for the quiz tomorrow, please do that as well. Anything you want to work on, we got a half hour left. That time is yours. If you're not going to stay on the Zoom call, have a great day, and we'll see you guys on Thursday.